So our next speaker is traveling from Bristol. He's part of this Smart Things Lab, I think they call it. Or
Smart Internet Lab.
Smart Internet Lab, the Smart Internet Lab of Bristol, which is one of the sort of higher profile labs working on 6G in the country. So we're happy to have Juan, Marcelo, Parra, Ullauri, who's going to be speaking to us about Flower plus Kubernetes. So take it away.
Yeah, thank you very much, Nick. Thank you, everyone. Thank you, Flower, for organizing this. It's been amazing this couple of days. So yeah, as Nick said, my name is Juan Marcelo Parra. I work in the Smart Internet Lab. As Dan earlier presented, we are a telecoms research group, but federated learning is a big topic in our research. Today, I'm going to be presenting my talk, designing a privacy-preserving Kubernetes operator for federated learning. So the agenda for today, I'm going to give a bit of introduction about myself, the background of federated learning, what is the or running example, what are containers and Kubernetes, that we have already some talks about it. What is the application of Kubernetes in machine learning and federated learning? What are some networking considerations that we need to take into consideration when using Kubernetes for machine learning, specifically for federated learning? Our proposal that is called KubeFlower is a Kubernetes operator for federated learning, a case study, a conclusion, and future work. So this is me. I'm from Ecuador in South America. I'm an electronics engineer with a specialization in telecoms, and I hold a PhD in computer science. My research focuses in distributed machine learning, of course, federated learning for networks, but also networks for federated learning and distributed machine learning. I also have background in explainability, autonomous systems, and data engineering. So, okay, going to the topic, the background. So yeah, I don't need to explain what federated learning is, but the case study that we are using and what is or run an example, we use this cross-silo example where we have two hospitals that are trying to train a model, collaborate to train a model, but of course they don't want to share the data because privacy concerns. Now, what are some cloud-native technologies for machine learning and federated learning? So as we have had many talks today regarding containers and Kubernetes and cloud and deploying federated learning in cloud environments. Two main technologies, cloud-native technologies are Kubernetes and containers. Containers are lightweight, standalone, executable software packages. They reduce the complexity of managing the underlying technology. The main container platform is Docker, is the most well-known, and Kubernetes is a platform for orchestrating Kubernetes and is workload orchestration. Container workload orchestration, it helps to simplify the deployment, scaling, migration, and management across distributed nodes. Some examples of Kubernetes for machine learning and for federated learning, apart from the ones that we've seen today, are Kubeflow, for example. That's the most well-known, I think, that I know. Kubernetes is also another example, and specifically for federated learning, there is Kubefate, and also Google Kubernetes engine for federated learning. All of these use Kubernetes and containers for deploying and managing the life cycle of machine learning and federated learning pipelines. But there are some implications when we use Kubernetes that we need to consider. And the main one is that when we use Kubernetes, all our nodes are in a flat network. So it will mean in this case, so for example, in the running example, we had hospital A, hospital B. When they are part of a Kubernetes cluster, all of them are in the same network, which means that these clients will be able to communicate directly with these other clients, which can violate the principles of federated learning and privacy. So specifically is a big concern when using Kubernetes. So I will invite you to everyone that is using Kubernetes for federated learning to read the paper, understanding the security implication of Kubernetes networking, because this is a big topic at the moment. So what we propose is Kubeflower, using Flowers as a backend to manage the the federated learning pipeline, and an operator, the Kubernetes operator, that controls or the networking and the lifecycle management. This is how it looks like. So we have the control plane of Kubernetes, where our operator would sits, and then the data plane where we deploy federated learning, and this will be a Flower server, Flower clients. We tackled privacy in a different from a different perspective that is more from a system level and in transit data rather than application level, as with differential privacy or secure aggregation that is other approaches. What we propose is network isolation. So we create networks on demand that assure that only all clients or could be divided either by zones or per device, per silo, per device. And we create the specific networks only for those nodes. So, for example, and you can see here there is a virtual network A that is specifically for this working node, and virtual network B that is for different nodes. We can create different types of network isolation, as I said, per zone, per node, or per client. And also on top of that, we add data packet encryptions. We use IPsec tunnels for communications in the pipeline. And yeah, and as I mentioned, we use Federated Flower as our Federated Learning manager. This paper I presented last week in the InfoComm's workshop on AI-driven, trustworthy, secure, and privacy-preserving computing. That 50% of the papers were on federated learning. So in telecommunications, federated learning is a big topic. For case study, we use our testbed in Bristol. We're lucky to have a testbed that is deployed around across the city. We have different nodes around the city. We have a data center, and then we can communicate. We have our data center nodes and our edge nodes, where we can deploy different experiments, communications experiments. We have fiber optic, 5G, Wi-Fi, etc. And to emulate the scenario of having cross-silo devices, we deployed two different pipelines of federated learning in two different geolocated edge nodes that we have, one in our data center and one in the MSHED museum. For the case study, we use the medical MNIST data set that is an image classification with the data sets consisting of 64 plus 64 size grayscale images. We use a simple CNN, and we use Flower and paired average for the federated learning pipeline. And for the running example setup, we use, as the previous speaker, you open a stack to deploy your resources in your testbed. On top of that, we have the Kubernetes, Kubernetes stack, and on Kubernetes kubeflower operator, that is the logic for deploying federated learning, and it builds the IPsec tunnel between the nodes that we have. So as you can see here, this is the hospital A, and these represent the hospital B. And we had two experiments in our case study. One was to actually showcase the flat network imposed by Kubernetes. So as you can see here, we run an experiment exchanging ICMP echo packets using Genus Ping implementation, and we try to ping all the nodes from hospital A to hospital B. And as you can see here, we were able to do it by using the default networking implementation that comes with Kubernetes. And when we use our approach, we can see here that there is actually isolation, so they were not able to reach each other. And our experiment number 2 is focused in the federated learning analysis regarding model accuracy and model loss. And as you can see here, there is no impact, just randomness in the training. We did encounter some overheads in the execution times around the 2%. They can be neglected if we consider the security and privacy benefits of the approach. And also we analyze the throughput. It of course increased when we use our approach because we add encryption with IPsec that adds encapsulates the packets and of course therefore use more bytes for transmitting a message. So for conclusions of future work, we have proposed network isolation to provide a privacy preserving approach in Kubernetes-based federated learning. We use data packet encryption with IPsec. Our main goal is to build scalable, sustainable, and trustworthy federated learning for networks, for the next generation of networks, CG. We plan to use differential privacy at the system level rather than local level. This is something that we are researching at the moment, and we want to use secure aggregation. We also will consider inter-cluster communication. So far, we have focused in isolation and communications within a Kubernetes cluster, but we are interested also, what about if we have different clusters in different cities, different parts of the world, how can they communicate each other in a secure manner? And yeah, basically we are working in this Kubeflower operator that hopefully we will be able to commit to the community, and if there is interest, we can work on it and iterate it and create a better version of it. Yeah, that's it. Thank you very much.
Thank you. So we could take one or two questions. Anyone here want to ask something? Or online, I guess. No? Okay. Yeah, we've got a question from our resident Kubernetes expert.
More or less. Okay. One thing thank you for the talk first. One thing I didn't quite follow is, can we use this infrastructure for simulation, or is designed for production?
For both, like in the previous example, they use OpenStack for running simulations, but we use it and try to emulate a real scenario. So you can run everything. If you have the computer power in your lab, for example, you can run Kubernetes and test all the clients that you want in containers as much as your power consumption. Your computer power allows you. Yeah. But yeah, if you have distributed nodes, as in our case, you can test them as in a real scenario. Okay.
And in a follow-up to that, for example, imagine if I want to do simulation, maybe something I want to do is to push dataset partitions to different containers, for example. Mm-hmm. Is this something you think is possible to do, or is it easy to do?
Yeah.
Have you done it?
Yeah, well, as the previous speaker said, that managing Kubernetes is not that straightforward. It's of course it's possible. There's something that's called persistent volumes and volumes claims, and yeah, you can do that. You can partition the data and store in different databases and try to access it in different manners.
Okay, yeah. Great. Well, that's good. Bit of good Q&A. So let's thank the speaker again. Thank you.